Hello dear students, once again welcome back to our channel. In this video I am going to explain the word problems of exercise 3.5, that is question number 4. Under this question number 4 we have 5 sub-questions. Let us move to the first sub-question, and in this question what it says: a part of monthly hostel charges is fixed and the remaining depends on the number of days one has taken food in the mess. When a student A takes food for 20 days, she has to pay rupees 1000 as hostel charges, whereas a student B who takes food for 26 days, she has to pay rupees 1180. And what is asked? Find the fixed charges and the cost of food per day. Okay, so as usual, how can we start? That means here the two variables are, we have to find out that two unknowns. Okay, so we have to give variable for the first unknown, that is we have to find out the food for each day. Okay, so let the food for the each day and the fixed charges. As a fixed charge comes first, so we can give the variable x for the fixed charge and the cost of food for one day, that is it can be taken as y. Okay, and here in this question we have two cases. From these two cases we can formulate equations and we will get a pair of linear equations in two variables. Okay, let us see what is the first case. In the first case, the first student A has taken food for 20 days. Okay, and the amount she paid is rupees 1000. Okay, and that means what is this 1000, children? That is the amount paid for 20 days food. Okay, that is we have taken food per the cost of food per day is y. So what is the cost for 20 days food? 20 into y. The cost of food for one day is y. So 20 day 20y. And we have to add fixed charge also, and that we have taken as x. So x plus 20y, that together will give 1000. Okay, so in the LHS we have to write x is a fixed charge and it for 20 days. So 20y is the amount for 20 days food is 20y, and we have to add the fixed charge along with that number of days, the cost of food for 20 days. And in second case, here the second student B has taken food for 26 days. So amount for 26 days food is 26y, and we have to add fixed charge, that is x plus 26, and the total amount she paid is rupees 1180. Okay, idea is clear, children, how the equations can be formed. So the second equation is x plus, this is the cost for 26 days food, and that is total amount is given as 1180. Let it be equation 1 and equation number 2. This can be solved either substitution method or elimination method, that doesn't matter. Okay, so I am going to eliminate the variable x from both equations, okay, by subtracting. Why it is subtracting? Both having the same coefficient. Okay, so in order to eliminate you have to subtract. Okay, so children, 1 minus 2 implies, the method is our convenience. Okay, don't stick on the substitution method or elimination method. Which method you feel easy, you can apply surely that method. Okay, that doesn't matter. So 1 minus 2 means we have to subtract, change the sign, that is minus, 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 the second equation. Okay, so this get cancelled. So 20y minus 26y is minus 6y, clear? And 1000 minus 1180 is negative sign, because 1100 is negative quantity, so 180 rupees. Okay, so from this you will get the value of y, that is equal to, y is equal to, see we can reduce, that is cancel negative sign, or y is equal to negative 80 divided by negative 6, right? So hence 6, the multiple of 180 is the 6. Okay, 6 is a factor, or 180 is a multiple of 6, so you can directly reduce. So So 6 in 6 one time, and 6 in 18, 3 6s are 18, so 30. So what is 30? That is the cost of food per day is we have taken as y, we have given the variable y, so that we got as rupees 30. Secondly, what is asked? We have to get the value of x also, okay, that you will get this from equation number 1. Okay, so from 1, okay, how this x can be written? From 1, x is equal to, what comes in the RHS, that you should write first without any change in the sign, and when we take 20y to LHS, from LHS to RHS, so positive 20y become negative 20y. Is it clear, children? Okay, so 1000 minus 20 into, what is y? Y we got as 30. Okay, so 30. Okay, or 1000 minus 20 into 3. 2 3s are 6 and 2 zeros. Okay, 2 zeros. So 1000 minus 600, and that is 400. So this is the cost, that is fixed charge. That is x represent fixed charge. So x comma y is equal to 400 for x, and 6 what we got? 30. 30 we have taken as cost of food per day. So this is the answer. Now the second question, it's a very simple question. Okay, a fraction becomes 1 by 3 when 1 is subtracted from its numerator, and it becomes 1 by 4 when 8 is added to its denominator. Okay, we have to find out that fraction. It's very simple question. So as usual, we can give the substitution for the variables. So here this is a special case, a fraction. So fraction means it has numerator and the denominator. So we can first suppose the required fraction as x by y. Okay, see if we are subtracting, so required fraction, let it be x by y. Okay, and in the first case, this fraction become 1 by 3 when, that is according to the first case, when 1 is subtracted from the numerator. That means we are making any change in the denominator. We just subtracting 1 from its numerator. Here the variables, one x is for numerator and y we have given as separate variable, that is y. Okay, so we are subtracting 1 from its numerator only by keeping its denominator as such. Okay, that is y, that is x minus 1, as 1 is subtracted from the numerator. The required fraction we have taken as x when 1 is subtracted from its numerator, x minus 1, and no change in y, the denominator. So it becomes 1 by 3. Okay, and in the case 2, that fraction become, this x by y become 1 by 4. So 1 by 4 should come in the RHS. When we are adding 8 to its denominator by keeping its numerator the same, that is x divided by y plus 8, because we are adding 8 with its denominator. Okay, so y plus 8. Okay, then how can we reduce into its standard form of general equation in pair of linear equation? Because here we have both having the denominator, just cross multiply. So we will make it standard form. Okay, the case is clear, children, how we formed the equations. Okay, so we can take this 3 to numerator by multiplying, since this 3 is under denominator. So RHS to LHS, so into. So 3 into x minus 1. So this denominator come to numerator under multiplication with 1, since 1 is in the numerator in the RHS. So 1 into y is y itself. Okay, so we can apply the distributive property. That means we can open the bracket using distributive property. Okay, so 3 into x, 3x. Okay, minus 3 into 1, 3 equal to y. But in the standard form, we are keeping the constant to RHS part when we are solving. Okay, that means we have to write that variables alone in the LHS part, so that we can take this y to LHS. So plus y become minus y. At the same time, this constant negative 3 when it goes to RHS positive 3. Okay, so it will be in the standard form. 3x no change since y from RHS to LHS minus y, and minus 3 become positive 3. So let it be equation number 1. It is clear, children, how we formed that in the form of general equation of pair of linear equation. Okay. And in the second case, same way, 4 into x, 4x is equal to, here the denominator y plus 8. As such, we can multiply with the numerator in the RHS is 1. So 1 into y plus 8 is y plus 8 itself. See, children, it will come like this. So if you are opening by multiplying with y, 1 means the terms will remain as such. Okay, that means we can take this y to RHS to LHS, that is 4x minus y is equal to 8. 8 is in the RHS. 1 into 8 is here. I have taken the variable, that is plus y into minus y. So we have now the second equation as 4x minus y is equal to 8. That can be marked as equation number 2. Okay. So, see, children, here also we can easily eliminate the variable y. Okay, that means here the coefficient, you see that when we are eliminating, you see that the coefficient of the variable, here the same, because here in the equation 1, that is minus 1, here also minus 1. Minus 1 is negative 1 into y. So negative 1 is its coefficient. Okay, so since the coefficients are same with the same sign, you have to subtract, then only that term gets eliminated. Okay, same sign we can add only. Okay, so here it get added only. So in order to eliminate, you have to subtract. That is the indication, that is 1 minus 2 implies, right? So change the sign, since we are subtracting second equation from the first equation. Okay, so change the sign. So positive 4x negative. So negative become positive. Here negative comes. Okay, so 3x minus 4x is negative x. 3 minus 4. 3 minus 4 is negative 1. So negative 1x is simply write negative x. This term gets cancelled. Here in RHS, 3 minus 8. Okay, that is negative 5. 8 minus 3 and its sign is a negative, since 8 has negative sign. So a negative gets cancelled. So x is equal to 5. Okay, that means x we have taken the numerator of the required fraction. Okay, so how we can get to the denominator? So from equation 1 or 2, you can write that with respect to y. We need y. So we have this 3x minus 3 equal to y as we multiplied, open the bracket. So we can substitute here. That means y is equal to, from here, okay, this equation, 3x, 3 into x is 5 and minus 3, that is 15, minus 3, that is 12. Okay, that is y is 12. Now we have numerator and denominator. What is the required fraction? X by y. Just substitute for the numerator x as 5 and the denominator y is 12. So this is all about the second question. Now we are solving the third question. This is very important problem. Okay. Yash scored 40 marks in a test, getting 3 marks for each right answer and losing 1 mark for each incorrect answer. First condition clear? Had 4 marks been awarded for each correct answer and 2 marks been deducted for each incorrect answer, then Yash would have scored 50 marks. Find the total number of questions in that test. That is the question. Is it clear, children? So here also we have two conditions, and in the first condition he scored 40 marks. In that case, okay, 3 mark is for each correct answer and 1 mark is for each incorrect answer. In that setup he scored 40 marks, and there would be a change, okay, if 4 mark is for each incorrect answer and 2 marks deducted for each incorrect answer, then Yash would have scored 50 marks. Under these two conditions we have to formulate equation, then we can solve. Let us start, children. Yes, in the 40 mark case, the total mark is 40, okay, this will be when 3 mark is for each correct answer. Okay, so we can, the total number of questions means the sum of correct answer and the sum of correct questions and sum of incorrect questions will give the total number of questions in that test. So we can take that number of correct answer is x and the number of incorrect answer is y. When we add that, you will get the total number of questions. Okay, so that is what we have done here. Number of correct answer is x and number of incorrect answer is y. Since 3 mark is for each correct answer and we have taken number of question as x, so 3 into x, the mark for correct answer is 3 into x is 3x. Okay, and mark for y number of incorrect answer. Okay, for incorrect answer 1. Okay, so 1 into y is y, and this we have to subtract from 3x. Okay, so his asset is from correct answer, that is 3x, and from that 3x you have to subtract the mark for each incorrect answer, that is y number of incorrect answer. So y should be subtracted from 3x. So this is the first. In this case his mark is 40. How we found the first equation, clear? And in the second case, instead of 3 mark for each correct answer, if we are giving, if the teacher is giving 4 mark for each correct answer, and since the number of x correct answer is remains the same, that is x number of correct answers, so mark from x number of correct answer is 4 into x. Understood? Okay. Unitary method. Okay, that is 4x. And in this case, in the second case, children, 2 mark is given for, deducted for each incorrect answer. That is, since y is the number of incorrect answers, 2y is the mark deducted from, deducted for each incorrect answer. So this 2y should be subtracted from the mark scored from correct answer, that is 4x. Okay, that is 4x minus 2y. In this case, second case, his total score is 50 marks. Is this clear, children? Okay. See, in the second equation, since 4, 2 and 50, okay, 2 is common. So you can reduce with 2 by dividing both LHS and RHS with 2. Each term should be divided with 2 so that you can get the simplified form. So 4x by 2, that is 2x. 2x and 2y by 2, that is negative y, that is 2 get cancelled, and 50 by 2 is 25. So after forming the equation, you see that any common terms, in all the terms, both LHS and RHS, in that case you can simplify, and using that simplified equation you can solve. Okay, by elimination method or substitution method, that doesn't matter. Okay, so let it be equation number 1 and this can be equation number 2. See, children, the first equation, nothing is common, no common factor between the terms. So we are keeping the first equation as such, but from the second equation you can get the simplified form of the second equation as 2x minus y is equal to 25. So I am using elimination method to eliminate one of the variable. Here this y having the coefficient is negative 1. Negative y means coefficient is negative 1. Second equation also negative 1. So having the same coefficient means you just subtract the second equation. okay, from the first equation. So minus y become plus, 25 become negative. Now after changing the sign, okay, we are doing here 1 minus 2. Equation 2 is subtracting from the first equation. Hence we change, for that we change the sign of the second equation. So 3x minus 2x is x. This term get cancelled. 40 minus 25 is 15. That means x is equal to 15. What we have taken x as the number of correct answer. So we have that as 15. And we should get the y also, number of incorrect answer, and their sum will constitute the total number of questions in that test. Okay. So in order to get y, you can substitute one of the equation, either 1 or 2. Okay. So y will be, so 3x minus y is equal to 40. Okay. So I am taking y to RHS from LHS. So negative y become positive y. Okay, and I am keeping y alone here, so that I have to take 40 to LHS, so minus 40, and I am keeping 3x in LHS without any change for the sign. So since here minus 40 is taking from RHS, so positive 40, so minus 40. So then hence you can substitute for x as 15 minus 40 equal to y. So 45, 3 into 15, 45 minus 40 equal to y, that is y is equal to 5, 45 minus 5. That means we have taken the x for correct answer, number of correct answer plus number of incorrect answer. The sum will give you the total number of questions in that test is equal to x plus y, that is 15 plus 5, that is 20. So number of questions in that test was 20 questions. Now we are solving the next questions, very important problem, that is the fourth question. Places A and B are 100 km apart on a highway. One car starts from A and another car starts from B at the same time. If the cars travel in the same direction, in the different speeds, they meet in 5 hours. If they travel towards each other, opposite direction, they meet in 1 hour. What are the speeds of the cars? Okay, it's very important problem, children. So here we have two cars starting from different places. Okay, let the car starts from A and the second car starts from B. Okay, what is finally asked? The speeds of the car, since they are moving in different speed in both situation, both cases. Okay, one is, the first case is in the same direction and the second case towards. Okay, that is in the both case they are moving in different speeds. And what is asked? That the speed of the first car, that car starting from the point A and from B, the car from B starting from the point B. Okay, let it be x and y. That is what we have written here. The speed of the car from A is x km/h and that of from B is y km/h. Okay, and after traveling 5 hours, they meet together. So in the first case, I am considering the cars which are moving in the same direction. From A, okay, and from B, they also moving in the same direction and they meet together, okay, after 5 years, suppose from at P. Okay, so the time taken by the first car A to reach at P is 5 hours. Here also B, that also 5 hours. After 5 hours, they meet together and they are moving the same direction. That is why I marked P after B. Okay, here the distance, and the distance between A and B is 100 is given. Okay, and time traveled, both cars is 5, the same time, but different speeds. Okay, so in order to form the equation, here also we have three very important units, that is speed, distance and time. Okay, usually we are writing that equations with respect to time. Here we are going to form the equation with respect to distance. Okay, since we have the distance in terms of 100 is given, distance between the places, so that we can easily formulate the equations. Okay, so from the equation, speed is equal to d by t. I am writing this with respect to d is equal to st. Okay, in the first case, the distance. What is the distance travelled by the car starting from the point A? So that is, this is that. Okay, AP is the distance. And for distance, speed into time. Okay, that means here the speed of the car from A is x and the time travelled, okay, is time taken by the car A to reach at P is 5. So we got the distance as 5x. Understood? Yes. And the second car starting from B. Okay, that car also moving the same direction. Okay, and the distance travelled. That car also taken 5 hours to reach at P. Okay, so in that case, if it is D1 and the second car, the distance travelled by the car B is suppose that is D2, and that is equal to, since D is equal to speed into time, so the speed we have taken y, okay, and the time for car B also 5 hours to reach from to reach P from B. Okay, that is here, that is 5y. So this D2 is the distance travelled by the car from B. Okay, so that can be represented by BP. Okay, and that is equal to 5y. BP equal to 5y, the distance travelled by car B. Okay, that is 5y. And D1, what is D1 represent? The distance travelled by the car from A, that is AP is that distance. So D1 is AP. Okay, so this is the way we can form the equation under the given condition. Idea is clear, children? Okay, and from this, how can we formulate the equation? Okay, here we have the distance travelled by car A and car B, and how can we form equation? For that, you look into the figure, children. Okay, here we have AB is given, the distance between the two places, that is 100 is given. Okay, what is this 100 or what is this AB? Okay, how can we write AB with respect to the distance travelled by two cars? See, children, this is AB. This AB is nothing but when you subtract this BP from AP, this AP, from this AP, if you subtract this BP, you will get AB, this much distance. Okay, for that, in order to apply this 100, that is why I represented this equation with respect to distance, and hence we got this AB as, see, AP, the total, the AP is the longest distance travelled by a car from A, minus BP, this quantity, this much distance from AP, you will get AB. Okay, so AP minus BP is nothing but this AB. From the figure, okay, from the figure, it is very clear that this AP 100 is AP minus, what is AP? The distance travelled, D1, the car A, that is 5x minus BP is 5y. So we got the first equation, 5x minus 5y is 100. Children, I told if you can reduce or simplify, you can divide with a common factor. Here is 5, you can reduce with 5. So 5x by 5 is x minus y, 5y by 5 equal to 20. That is 100 by 5 is 20. This can be equation number 1. Is this clear, children? This is the equation from the first case. And from the second case is that what? That is when the cars are moving in opposite direction. Here the case 1, same direction, different speed. Then we got the equation. And the second case, opposite direction. In that second case also they are moving in different speeds, okay, and they have taken 1 hour to meet together, 1 hour. Okay, one car is moving in this direction towards the right side, suppose, and another car from B is moving towards A, to the left side, okay, and they met together, okay, after 1 hour. Okay, so the distance travelled is here, suppose the meeting point is Q, that is distance travelled by the first car, that is car from A, is AQ. Okay, so what is AQ? In the case 2, AQ is the distance travelled by the car from A. Is it clear, children? And BQ is the distance travelled by the car from B. Okay, so this AQ is, we know what is distance, speed into time. Okay, so the speed we have taken as x for car A, so x into, and time taken to reach at Q is 1. So x into 1, okay, speed into time, that is x. Okay, and the car from B, okay, that is, and they met after 1 hour at Q, so this BQ is the distance travelled by the car from B, and they have taken 1 hour. And speed is y km/h. So y into 1, that is y. Understood? And in terms of this AB, we are formulating equation in terms of AB. Okay, what is this AB, children? From the figure, AB is nothing but AQ plus BQ. That is, AQ is the distance we got as x, that is AQ plus BQ here, okay, AQ plus BQ equal to AB. From the figure, this AB, the total distance AB, that how they are apart, what is the distance from A to B, is equal to AQ plus BQ, or x plus y equal to 100 is given. Okay, that is why we have written the equation with respect to distance. Okay, so we can write x minus y is equal to 100. This can be equation number 2. So in order to get one of the variable, okay, what to do, children? Okay, here we x plus y, children, x plus y, the distance AQ plus BQ will give you the total distance, that is AB, distance between A and B, that is given as 100. Okay, so I am going to add, because they are opposite sign, so you can just add 1 plus 2 implies, this term get cancelled, 2x is equal to 120, 20 plus 100. Okay, so x is equal to 120 by 2 is 60. Since it is speed, its unit is km/h. Okay, and in order to get y, the distance, the speed of the car B, okay, that is from equation 1 or from equation 2 you can get y. Okay, so here y is equal to minus y, go to that side, or we can get from this equation 2, that is y is equal to, from 2, y is equal to 100 minus x, or 100 minus 60, that is 40 km/h. This is the distance, this is the speed. We have taken y as the speed of the car from B. Okay, that is, speed is 40 km/h, and from A, the car from A, that is, we have taken the speed as x, that is 60 km/h. So these are the different speeds of both the cars from A and B respectively. It's very, very important question. Now we are solving the fifth question, that is last word problem of question number 4. It's very, very important question. The area of rectangle gets reduced by 9 square units if its length is reduced by 5 units and breadth is increased by 3 units. If we increase the length by 3 units and the breadth by 2 units, the area increases by 67 square units. Find the dimensions of the rectangle. Dimensions means length and breadth. Rectangle, since it is plain figure, only 2 dimensions. Okay, so we have to find the length and breadth of the rectangle. Okay, see, suppose this is the rectangle having the length x units and the breadth as y units. Here also we have 2 conditions. From these 2 conditions we will get the equation. Hence we have pair of linear equation can be easily formed. Here a rectangle with length x unit and y is the breadth. What will be its area? Area will be length into breadth for rectangle, that is L into B. Hence it will be xy is the area. This area gets changed, okay, as we make changes in length or breadth. That's clear. Okay, so in the case 1, area reduced by 9 square unit. If it is x length and y breadth, the area is xy. Okay, if we reduce, that area get reduced. Okay, this xy get reduced when we reduce the length by 5 units. What is the length? Initially we have taken the length of the rectangle as x, and from that x, if we subtract 5 units, so the new length will be x minus 5. Okay, if you reduce the length by 5 units and if we increase its length by 3 units, in the starting the breadth is y, so if you increase means plus y plus 3, its area get reduced by 9 square units, that is xy is the area, and that should be that from that xy we have to subtract 9. That is xy minus 9 is the new area as we make these changes upon length as well as the breadth. Minus 5 and adding 3 to its breadth, that is y plus 3, that area xy is reduced by 9. Okay, in the first case, after making these changes, we will be getting area as xy minus 9. Okay, in order to solve this LHS part, we can multiply x with the second factor y plus 3 and with minus 5 and the second factor y plus 3. This is equal to xy minus 9. Okay, so term by term multiplication, open the bracket using distributive property. So xy, x into y plus x into 3, 3x minus 5 into y, 5y minus 5 into plus 3 minus 15, clear, equal to xy minus 9. Okay, xy, positive xy, and in RHS also positive xy get cancelled. Okay, and we have 3x, no other like terms with the 3x minus 5y. Here we have 15, negative 15. We are solving the equation. We are keeping the constant in the RHS part. So negative 15 come to RHS, that is positive 15. Negative 9 is already there. So negative 9 plus 15 is 6. Okay, that is positive 6. Say 3x minus 5y here equal to 6. This is the first equation, since we can't simplify further because no common terms. So this can be equation number 1. And in order to get the second equation, see the case 2. Here if we add 3 to the length, so x plus y, we are adding the units in the second case, both with the length and breadth. So y plus, if we are adding 2 with its breadth, so y plus 2, its area also get increased. So xy is given as increased by 67 units. So 67. How we form this equation is clear. In the second case, we are adding 3 to its length and 2 with its breadth. So area get increased by 67 units. So xy plus 16. The area was xy. So after adding 67 means xy plus 67. Understood? So as usual, the previous case, we can simplify by multiplying this with x. Okay. So x into y plus 2. And the second term plus 3 into y plus 2 equal to xy plus 67. So term by term multiplication or open the bracket using distributive property, x into y xy, x into 2 2x plus 3 into y 3y, second term, okay, plus 3 into 2, that is 6, plus 6, all are positives because we are adding length and breadth, some units with length and breadth. So xy plus 67 comes in the RHS. Here xy and xy, both LHS and RHS have same sign, get cancelled. So 2x plus 3y, okay, when this 6 comes to the RHS, negative 6. So positive 67 is there in RHS. So 67 minus 6 is 61. So this is the equation. We can't also simplify because 2x plus 3y equal to 61. No common factor. So as it is, will make equation number 2. Understood? So let us start the elimination method. Okay, if you want to eliminate one of the variable, what is the condition? You can easily do it only when both having the same coefficient. Here x having different coefficient, y also. So what is the only method? Multiply with the coefficients of the second equation with the coefficient of x in the first equation, and first equation with the 2, and second equation with the coefficient of x in the first equation 3, which implies we are first multiplying equation 1 with 2, okay, all the terms. So 3x into 2 6x minus 2 into 5 10 y and 2 into 6 12. This is equation number 3. And in the second case, equation 2 with the coefficient of x, that is 3 2s are 6x, 3 3s are 9y equal to 3 into 61, okay, 180 plus 3 183, 61 into 3, this can be equation number 4. Okay. Now in order to eliminate x, we made equation a coefficient of x same, so minus, so get cancelled. So negative 10, negative 9, negative 19y is equal to negative 183, okay, minus, that is 12 is positive, that means you will be getting what is it, 171, isn't it? Okay, 3, 2 minus 3, that is you will be getting 171, and that is negative. 183 minus 12 is 171. Okay, in the next step we will get y by dividing negative 171 divided by negative 19. Okay, and since 19 is a prime factor, this negative sign get cancelled. Okay, 19 is a prime factor, okay, prime number. Okay, if 9 into 9 is 81. Let us see what is the product of 19 in order to make the unit place 1. If you multiply with 9, 81, 8 carries, yes, 9 plus 8 is 117. Okay, that is 9 times. So y is equal to 9 units. Okay, in order to get to x, you can substitute, okay, in 1. Okay, what is the first equation? 3x minus 5y is equal to 6. Okay, so from this equation 1, okay, we can write equation 1 with respect to x. Okay, so 3x is equal to, okay, from equation 1, okay, 3x is equal to 6 plus 5y, minus 5 becomes plus 5y. 6, okay, plus 5y, that is 6 plus 5 into y is 9, that is 6 plus 45, okay, that is 51. This is 3x, no, not x simply. In order to get x, you have divide 51 with 3. Okay, that is, yes, 3 in 5 one time, okay, and in 2, 21, that is 7. That is 17 units. Okay, that is x we have taken as length and y is breadth, and that is we have seen that 17 and 9. These are the length and breadth of the required rectangle. Okay, after making these changes, we can easily calculate the values of that measurement of length and y. Okay, this is all about exercise 3.5 in case of word problems. We have completed 5 word problems. Okay, so each are very important. Thank you children. Thank you for watching and supporting my channel. Thank you all.